Imagine you're out shopping and you come across a bottle of wine that costs 7 radical $10. Would you know offhand how much that is? Probably not. 7 radical 10 means 7 times the square root of 10. But 10 is not a square number. Nothing times itself gives you 10. So that makes radical 10 irrational. And irrational numbers, when you write them out, the decimal part goes on and on and on without any repeating pattern. So this would be kind of a weird number to find on a price tag because money only goes to 2 decimal places. Although the price of gas goes to 3 decimal places and we just rounded off to 2. So maybe not that weird. The point is, you wouldn't buy that bottle of wine until you put 7 radical 10 into terms that you understand. So why is it that when your high schooler works on a math problem and they get 7 radical 10 as an answer, do they not question it? They might just walk out with a $200 bottle of wine. Kids start working with radicals around grade 8, but they often think of them in terms of radical rules, like how do I simplify a radical expression? How do I multiply and divide radical numbers? But they don't think of radicals as quantities. But they are. Radical numbers are an amount. 7 radical 10 is an amount. It has a spot on a number line. So writing 7 radical $10 on a price tag is really no more absurd than writing 7 radical 10 as an answer to a math problem if you don't know how much it is. When kids are in elementary school, we drill it into them over and over. Check your work, check your work, check your work. But when they get to high school and they're working with irrational numbers, they often just don't. Here's a typical trigonometry problem that your child might come across. They're given a right triangle with angles marked 30 degrees and 60 degrees, and a side of 12, and they're asked to find the other 2 sides. Now this is a special right triangle. What makes it special is that it's half of an equilateral triangle, but we'll talk about that another time. Your child may have learned about the relationship between the sides in a 30, 60, 90 special right triangle, that the shortest leg is x, the hypotenuse is 2x, and the longer leg is x radical 3. So they may just use that information and say, okay, well, if x is 12, then 2x is 24, and x radical 3 is 12 radical 3. Now, often they're asked to give an exact answer, so they have to leave it in radical form. They might just say, okay, I'm done. But how do they know if their answer is reasonable? Well, I can see that 24 is reasonable because this side of the triangle looks like double this side, and 24 is double 12. But I don't know about 12 radical 3. So you've got to convert 12 radical 3 into an approximation that makes sense to you. You can use your calculator and type in 3 square root sign, which will give you about 1.7, times it by 12, and that gives you about 21. Knowing that this side of the triangle is about 21 allows students to then figure out, is my answer reasonable? Well, I can see that it's a lot longer than 12, and it has to be shorter than 24 because the hypotenuse is always the longest side in a right triangle. So yeah, this checks out. Now, if you want to approximate the value of a radical, you can do that without a calculator too. So if you want to know how big is radical 3, the square root of 3 is not readily apparent because 3 is not a square number. So you sandwich it between 2 numbers that are square numbers. 1 is square and 4 is square. Take the square root of those numbers, and the square root of radical 3 will be between those 2. So the square root of 1 is 1, the square root of 4 is 2, and so the square root of 3 is going to be between 1 and 2. Picture a number line and decide which number is 3 closer to. 3 is closer to 4. So the square root of 3 is going to be a little closer to the square root of 4, which is 2, than it is to the square root of 1, which is 1. And that's how we get about 1.7. Trigonometry is all about the relationships between sides and angles in triangles. If your child doesn't understand the answers they're coming up with, then what are they learning? You can help them with their homework by encouraging them to make sense of their answers. That sends the message that math should make sense, and it just might get them interested in what they're learning.